right, so remember, this is not examinable or assessed in any way. It's just me adding on some theory for you to understand. Those who want to do methods, that's going to be 3/4 of your course. So understanding the theory is what's useful. So here we go. There are two key terms that you'll need to understand the difference between. One is called average rate of change. One is called instantaneous rate of change. Average rate of change you already have learnt. It's just a new name for the gradient. Fill this in. So in year 9 you learnt the gradient. And it was given by the letter m in an equation. So m was equal to, so I'll just remind you in case you've forgotten the linear equation, y equals mx plus c. And m is the gradient. And that was calculated by finding the slope or the steepness of a line using 2 points. That's why you have x1 and you have y1 for 1 point, and the other one is the second point. Visually, this is what you were doing back in year 9. You have 2 points, so say this point is point number 1, so x1, y1. Then you have a second point, x2, y2. And the line that connects these two has to have a certain steepness. That steepness is calculated by finding the vertical height divided by the horizontal height, which is that. Okay? Now, why do we call it average rate of change? Well, here's a bit of a logic to it. You see, I'm just going to draw it separately. You don't have to copy this bit. You see, if I said that a car was driving, and this is the distance, okay, so this y-axis talks about distance. So I go up, I go down, and I go further out, right? This is the time. What we can see is that at every single point in time, I have a different distance as I travel. But let's say I wanted to know from 1 second to, let's say, 5 seconds. Okay, I want to know from this point to this point. What was the overall distance within 1 to 5 seconds, which is 4 seconds? You see that? So 1 to 5 seconds, that's a total of 4 seconds. In 4 seconds, what was my distance overall on average? That's why they call it the average rate of change, because you're seeing after 4 seconds, you can see a rate. You see, so if I pick 2 points, overall, I know the distance is different, but overall, that's my max distance and that's my minimum distance. So overall, what is my height? So here, if we were to calculate it, this is what you would have done. You would have said, take y2 minus y1, so you work out the actual total distance, divided by the total time. So from 1 second to 5 seconds, that's a total of 4 seconds overall. So if I did it hypothetically, let's say you traveled 80 kilometers and you started off at 20 kilometers away from the origin or from the starting point. Let's say you calculated from that, from 20 to 60, what's the total distance you have covered? 60, very good. 60 kilometers. So from here, that was 20. To go all the way here, you've now traveled 80 kilometers in total, but that's 60 kilometers difference. How did you know? y2 minus y1. But you did that in 4 seconds. So what's my average rate of distance covered? So my average rate would be 60 kilometers. That's my total distance divided by the total time. Well, 5 seconds is where I ended up, but I started at 1 second. So the distance between it is 4. So you'd say in 4 seconds. So what would the rate of speed be? Your average rate of speed would be 60 divided by 4, which is what? Is that 15? 15 kilometers per second. It was really fast. Yeah? That's what essentially that rate is. That rate is your gradient, but it is a rate of change between 2 points, which is what you were doing in year 9. You only use 2 points to understand rate of change. So, the difference and what calculus is, and just to sum it up for you, write 2, or actually underline the word 2 over here. So you can find the gradient, which is a rate of change using 2 points. That's what year 9 theory is. What makes it a senior level theory is that this time, when we say instantaneous rate, we're asking you, what is the gradient at a single point in time? That means, and what the difference between instantaneous and average rate is the fact that you need only 1 point versus 2 points. Visually, if I had to show you what I mean, you see, along the way, if we're talking about a rate of change, you can actually think of it as, at this particular point, right there, you had to be at a certain speed, right? You had to be traveling at a certain distance at a certain speed. So right at that moment, what is your speed? What's your average speed at that particular moment? See, we were only able to find the average speed between 2 points. You took the total distance divided by total time, but you needed 2 points to do it. What if I wanted 1? So I wanted to know the gradient at exactly that point. Now that's called a tangent line, the line that touches the curve exactly just 1 point. What would the rate be? That study is called calculus. The study of how do you find the gradient of a straight line with just 1 point, because you've only done it with 2. And today's theory, I'm going to show you logically how they came to that point where you can actually find the gradient of 1 point rather than using 2 points. And that's very special, because if you don't need 2 anymore, being able to find 1, there's a lot of things that I can teach you why 1 point and knowing the gradient is so powerful in terms of applications, in terms of knowing the exact speed at that specific moment, or as specific, let's say, a volume of a tap. You know, when you're leaking at that particular moment in time, what's the rate of change? How much is it changing at that particular point? Yeah? All right. So what do you take out of what my explanation was? 2 things. If what I just described was very much to take, 2 lines. 1, this is year 9 stuff. Average rate of change just means gradient using 2 points. Instantaneous rate of change just means finding the gradient with 1 point. Does that make sense? So if you were to write your own notes right now, just right here, gradient with 2 points. That's pretty much what I'm trying to say. And this one, gradient with 1 point. That's all it is. In a summary, in a nutshell, if you had to take what I just described, what's instantaneous? Just to find the gradient with 1 point. The other one is gradient with 2 points. Yep.
What maths are we doing? This is like physics accelerated.
I'm not sure if it's in the curriculum. I feel like they would, because when I spoke to the accelerated kids who are in the year 11 method stream, they said they know calculus. But then when I actually delve deeper into it, they don't actually know calculus. They know how to, which is what I'm showing you in the second session. So this is the theory to the how to. Yep. So the first session, I'm teaching you the background. I'm teaching you the theory. If you get it, great. If you don't, you just do what most AP kids do, which is they just learn the procedure. It's kind of like multiplication. Most of you understand 219 times 32, and you guys will know how to do the algorithm to it. Primary school kids know how to do it. But if you break it apart and you say, well, why is it that we do 3 times 9, and then it's 27, and then carry the 2? See, not many kids can explain to me why that happens. Why do you carry the 2? Why does it work with division, that, short division, long division? You learn an algorithm. So second session, I'm going to teach you an algorithm, but it doesn't have the theory. So most kids learn algorithm. They just go through maths by memorizing the process, but they don't get it. It doesn't actually make sense to them. This session today is me going through theory, which means that you have to listen and think with me. If it makes sense, great. If it doesn't, you're going to learn algorithm next session, and that's the easier part to do. Yeah? So here we go. Let's look at the theory. So I just talked about average rate is finding a gradient with 2 points, which is year 9 mathematics. Instantaneous rate of change is to find a gradient with just 1 point. So how do we do that? Well, I'm going to guide you by first doing one example of average rate, just so that you get used to the language. So here it says, find the average rate of change of the function. So this is my function. We don't know what the curve is, but we do know we are trying to find it between -2 and 5. So here's my point, -2, 4. Let's say it's around here. So that's point A, -2. And then 5, let's say it's over here, point B. When they say average rate of change, they're really just saying, I started at this point with a certain Y value, Y1, and then I ended up at B, which is now Y2. So I've clearly increased. How much have I increased by? over the duration of this time from -2 to 5. So let's work it out. From -2 to 5, what's my distance? How many units? 7. So I got 7 units of whatever that represents. Who knows what it represents? But the vertical distance, I went from y1. What's y1 equal to? 4, because it says here -2, 4. So this point here must be 4. And then y2 is clearly at 20. So I went from 4, I started at this point, and after 7, whatever this unit is, I've ended up at 20. So what's my vertical distance? How much has changed? 16. Now the logic of what you just did there was you did 20 minus 4, so y2 minus y1. Horizontally, you did 5 take away -2, so 5 take away -2. And this is what you ended up with. You got 16 on the top. 5 take away -2 becomes +2, so it's 7. And this is your, what we call average rate of change, which really is your gradient. I just don't know what the y-axis and the x-axis represents. So if I said it was distance, then you would say it's 16 kilometers per whatever 7 represents. Get me? So the scenario I gave you before was distance by time, but it could have been anything. It could have been $16 per 7 hours. You know, I don't know what that number actually represents, and maybe the -2, that doesn't make sense with time. Can't have -2 time. But the idea is that that's what the rate means. Yeah. So whatever this unit is on the top, that's 16 units per 7, whatever these units represent, which I don't know. Okay, so this is your y-axis and this is your x-axis. So far, so good? All right, let's go to the actual theory. So we clarified, this is year 9 mathematics, gradient with 2 points, gradient with 1 point. So I just showed you how to find the gradient using 2 points. So we did y2 minus y1, x2 minus x1. Great. Rowan? No? No question? Let's now look at the very first concept, because we're interested in finding instantaneous rate of change. So we know how to find average rate. We don't know how to find instantaneous rate yet. Let's say we want to find the gradient of a tangent line. Remember, tangent line is a straight line that touches the curve exactly once. Where do I want to touch? At x equals 2. So here it says at x equals 2. So on the graph, this is clearly 1, 2, 3, 4. So on the graph, when I say I want to know at x equals 2, this is the point where x is equal to 2. Now the function, that curve is a quadratic curve that is y equals x squared. So this curve here is the result of squaring whatever x is. So at x equals 2, what should the y coordinate be? 4. Very good. Because the function said if x is 2, I sub 2 in, 2 squared gives you 4. So therefore, at this very point, I should have 2, 4. When I say I want to find the gradient of a tangent line at that point, what I'm actually saying is this. I'm saying there is a line. Oh, wow. I'm just going to rub that out and do it again. There is a line that touches exactly just the 2, 4 point. This line is made up of y equals mx plus c. That's a straight line that you learned from year 9. What we don't know is this, m. If I can find the gradient of a line, and I can type it on Desmos, I want it to cross exactly at 2, 4. Nowhere else. It has to skim the surface of this graph, because that gradient represents rate. And whatever the scenario is, if this scenario represents distance and time, I know the rate at this one point. What's the problem? We haven't got a formula to find the gradient of just one point. So what do? We pick a second point. So we say, all right, I didn't have a second point, so I'm going to make up one now. I'm going to pick, let's pick the next one. Let's pick 3. At 3, it should be right above here. Let's pick 3. So here's my second point. 3, when x is 3, what would the y value be according to this function? 9. So if I want to work out the average rate, which I can, see the gradient, I can find between the green and the purple dot or pink dot. what would the average rate or gradient be? So gradient is equal to y2 minus y1 over x2 minus x1. Here's my second point. That's my first point. I picked a second one randomly. Could have been anywhere else. I just picked 3. Y is 9, sorry. Y2 is 9. Minus y1, which you told me was 4. Divided by x2, which is 3. Minus x1, which is 2. Let's work out the gradient between this point, which I'm going to give it a name. Let's call it point A, point B. So from point A to point B, what is the gradient of that green line? 9 take away 4 is 5. 3 take away 2 is 1. So I got a gradient of 5. Okay. What is the problem? Let's have a look. I found the gradient between 2 points. Now notice, which line did I want again? I want the purple line. I wanted the tangent. Is the green line the same as the purple line at the moment? No, it's not the same steepness. Which one's steeper? The green line. So it's too steep. I need it a bit flatter because I'm going to try to move it so that it turns exactly like the purple line, because right now I'm off. But I'm off because I chose number 3. I chose x equals 3, but it doesn't have to do 3. I could have done 2.5. Now if I do 2.5, would that be closer? Yes, it would. See, if you think about it logically, try to picture it. I picked this. This is now 2.5. And then I told you to do the same thing again. 2.5 and then 2.5 squared. That's your y value. Can you see how the line, even if we're not calculating it, if I drew this black line connecting the purple and the pink, can you see how it's now getting closer? So that purple dot and this pink dot was better than choosing 3. If I choose 2.5, it's getting a bit closer. So logically, 2.5 still isn't exactly the same line as the purple line. So instead of choosing 2.5, what else can I choose? 2.1. Can I get better than that? No, 1 will be further on this side now. So I want to be as close, because remember, I want the point exactly at 2. I want it to be exactly at 2. So I'm going to draw it again. I want it exactly at 2. So I've chosen 3. You said it was too far. You said it's too steep. We tried 2.5, and you can already see it's closer, but not exactly. And then Yuna said maybe 2.1. How can I do better than that? 2.001. Now, what's the pattern? What am I doing? Smaller and smaller, but really close to 2. The closer I am to 2, the better. But I'm just slightly off. I don't have to be exactly at 2. But the fact that if I can get really close, that means the line gets even closer and closer to the tangent line. True? This is called the first principles. You see, when I show you the actual rule, what you just described to me was exactly what we just did. You just described to me, you see, this is your y2. This is your y1. Now notice why the h's cancel out. I'm going to show you soon. But really, this formula, this is the gradient. And why do you think this symbol, what that symbol means, is exactly what you just described to me? That is us choosing a point so that the distance between the first point and the second point is as close to 0. That's what that means. Because we went from, I chose 3, that was 1 unit away. Then you said, well, let's do better. So I said, all right, let's do 2.5. That's 0.5 away. Then Yuna said 0.1, I'll do 2.1. I'm now 0.1 away. Then Olivia said 0.00001. So I'm 0.00001 away. So you can see that H represents the distance. That H represents the distance away from the original point to the second point that we're choosing. Okay, so if I draw the graph again, so we go visualize back at the graph. See, I started at 2. I want exactly at 2. I want the gradient at 2, which is the purple line. When I chose a random point, I said 3. You told me the green line was too steep. So I said, let's get better. We chose 2.5, and when I connect it, you can see it kind of sits just in between. If you want to get better than that, I'm going to have to choose 2.1, sits in between the black and the green. Then if I choose 2.01, it should even get closer and closer to the purple line. See what I mean? So it gets flatter and flatter and flatter. It gets closer to the purple line. So the smaller the distance from 2, and that h value that you add on extra. See, if I did 0.1, 2 plus 0.1 gives you 2.1. That's the next bit. If I did 0.5, then it's 2.5. If I did one distance away from 2, then it's 3. So what the theory is saying is, what if you made h as small as possible? That's what that arrow means. It's saying, what if you made h infinitely small, theoretically, infinitely small? What would the gradient tend to? And what we can see is the more smaller the distance is, the closer to the purple line you'd get. That's what this formula, which is called the first principles. Here we go. I'm just going to roll down. It's on the back of your page, the back page. This formula is actually just the formula to say, let's make that second point infinitely close to the first point. Not that it's exactly the same, let's just say it's infinitely close. What would that tend to? Yeah. Yep, that's true. I didn't check the roll before. So, let's see where this formula comes from. So we're wondering where this formula comes from, but at least you understand this bit. That was the key bit that makes this called calculus, because all the formulas that you learn, or the year 11s and 12s learn, they can skip this theory and they just learn the formulas. But the formulas come from this bit. This whole bit, this theory about making h infinitely small to then find the gradient of one point. That's what first principles is, and that's where it all began. Yeah, so the theory is to find the gradient with just one point. And how we do that is we still use 2 points, but the second point is so infinitely close that you technically, on a theoretical point, are able to figure out the 1 because you're approximating closer to it. Yeah? So, let's see how the theory pans out. So why is this the formula? Let's show you. Flip over to the back of the page. Here we go. So here's the theory. I gave you a number before. So I said 2. I said at 2, and then you told me the y value is 4. So this was 2, 4. So what we're going to do now is we're going to generalize this now. Instead of just 2, I'm going to call it x. Okay, so 2 is my x. How would you find the y value? Well, you told me sub 2 into the equation. And then you would have got 2 squared. That's how you knew this was 4, right? So then if I told you it was x, then subbing x into this equation, you now get x and x squared. True? So if this was 2, then it becomes 2 squared. If this was 3, this would be 3 squared. If it's x squared.
Is f meant to represent the calculated thing?
Yeah. Yeah. And I'm going to show you on the CAS so that you can see how we do our calculations as well. Yeah? Now, here's the theory. This is where the theory comes in. So we need to now pick another point. So I've got x on the x-axis. I need now to pick a second point. But it needs to be h distance away. So I'm going to zoom in so you can see. I need it to be h distance away from the original. Now, I don't know how much that h is going to be, because we said 0.1 before, and we said 0.0001. So h can be a very infinitely small number. So what I'm saying is that means the next x value must be x plus h. True? So you've got the first point is x, second one must be then x plus h, whatever h is. H is a very small number. But if that's true, then that means at x plus h, I should have a second point. When it's x plus h, I can then find the y value. Now, have you got x plus h? So that's the original point, plus h is the infinitely small bit. If this is your x value, all right, kind of like as a number point reference, if it was 2 plus 0.1, then that's 2.1. So how do you find the y value? You would sub 2.1 back into the equation. So you would say it'll be 2.1 squared, true, because the function is x squared. So instead of 2 plus 0.1, we're now going to write it as x plus h squared. Have I lost you there? Yeah? Okay, let's dial back a bit. So remember, I said f of x is equal to x squared. I asked you if x was 2, what was the y value? You said to me 2 squared. So that gives you 2 squared. Then I said, all right, well, what if I gave you 3? You said, oh, sorry, I said 2.5, I think it was. 2.5. You said, well, define the y value is 2.5 squared. So therefore, the point is 2.5 squared, right? What I'm asking you now is, well, what if I did f of x plus h? See, this is your original, and you're adding on just a little bit more. How would you find the y value? The pattern would then be x plus h squared. See what I'm doing? All I'm doing is I'm just subbing in what this is. X goes in, it's x squared. 2 goes in, it's 2 squared. 2.5 becomes 2.5 squared. It's x plus h squared. So far, so good. So that means the coordinate, therefore the coordinate would be x plus h, and the y coordinate would then be x plus h squared. You see what I'm doing there? So I'm doing exactly what we've wrote here. When it's 2, it's 2 squared. When it's 2.5, it's 2.5 squared. So if this is x plus h, that must be x plus h squared. Let's write the two coordinates that we have. And you'll see where the first principles comes in. So here. First one was, if I had x, then you told me it's f of x. Or technically, sorry, our example was x squared. That's point number 1. So point 1. So there's x1, y1. My second point, I said pick one that is just a bit further than the original. So here's my second point. X plus h. And we agreed that it's x plus h squared is my y value. Here we go. This is x2, y2. If I asked you to find the gradient of these two now, to find the gradient, this is what you would say. y2 minus y1 divided by x2 minus x1. So here we go. y2 minus y1 over x2 minus x1. Can you see now? I then get x plus h squared, that's my y2, minus my y1, which is x squared on the numerator, divided by, and notice now x2 is x plus h minus x1, which is x. In the denominator, what can you cancel out? The x's. X take away x cancels out. That's why in the formula, if you look at the first principles, notice it's only h. Because the x's will always cancel out. The original number is always going to cancel out. So x2 minus x1. Now, let's have a look at the numerator. That x plus h squared was actually just the result of you subbing x plus h into the function. So that's why this is known as f of x plus h. This one is the actual function, which is why that's known as f of x. So if you put it together, can you see why now this is really just f of x plus h minus f of x all over h? What is this formula really saying? It was literally just finding the gradient of 2 points, but the difference is this. The difference was that at the front, we said, what is h? H was the distance that you chose, and we all agreed to make it as small as possible. I went from 3, like 1 unit distance away, to 2.5, which is only half distance away, to then Una said 0.1 distance away, to then Olivia saying 0.0001 distance away. What if you can make it even smaller than that? Because then that gets really accurate. So this is what the formula is saying. What if you made h infinitely close to 0? So I mean the distance is very short. That formula there allows you to then solve the problem. Now, let's put this together and actually do it as an example so you can see what the answer actually tends to. Okay? So, with the space that you have on the bottom, let's actually put an application now. So what was the problem I gave to you guys before? This is what I gave to you. I'm going to put on Desmos so you can visualize. Here we go. Let's have a look at Desmos. Where is the Desmos? Okay, Desmos is here. Here's your y equals x squared. That's your function. You told me when it's x is 2, y is 4. There's the coordinate. 2, 4. We're trying to find a gradient of a line that will touch that curve exactly once. Okay? What we don't have at the moment is if I picked the point 3, you told me 3, 9. Now I'm going to do it on a CAS. I'm going to show you on a CAS on how you can find the tangent line. Yeah, to find the equation of a line. Here we go. Actually, you can't do this bit. I'm going to do this bit quickly. I'm using some user-defined codes, so you won't know what I'm doing. All right, what is it? We've got 2 points, 2, 4, and the other one was 3, 9. So I'm cheating just to get the equation. 5x minus 6. All right, here we go. So, can you see? That was the line that we said. That's the line. That's a problem. It's not exactly at the point 2 that we want. It crosses through 2 points. So then we picked another one. We picked another one. And what we want to do is we want a gradient that actually sits exactly at 2. Right? So let's do the calculation. Here we go. Menu. Calculus. So if you have this, write down the codes for this one. So menu, 4, calculus, 4, calculus, and you will see number 9 called tangent line. So menu, calculus, and tangent line. So it's menu 4, 9. So I'm doing a shortcut version so that I can prove to you this is what you're going to calculate with the first principles. This is by CAS, but I'm going to show you how to do it by hand, yeah? So by CAS, menu 4, 9. What's the equation I gave you? It was x squared. That's the function. That's the curve, right? Type in x squared, comma. Where do you want it to be at? You want it at x equals 2. Because remember, you're using only 1 point. You're finding the gradient of 1 point. When I press enter, it tells me the equation that will actually cross just at 2. Nowhere else, just touches the curve exactly at 2. So clearly the gradient's 4 there. So watch what happens when I go back to Desmos, and watch this. When I type in y equals 4x, was it minus 4? Yeah, minus 4. I'm going to zoom in, and you will see the black line. Is it black line? Yes, it is the black line. Maybe I should change the colors so you can see. And then change the colors to make it orange. Can you see the orange line? The orange line will touch the red line just once. See, that's the red line over there. Can you see the red line? But if I keep going, can you see it only just touches exactly, as I get to this point, touches exactly at 2, 4. I just got the equation of the straight line that touches the red line exactly once. Now look at the red line, the orange line, and the purple line. See how it's off? Because 5x minus 6 is really close. What's the problem? That's a 1 gradient difference compared to this one. So even though I picked 2 points before, I said 2 and then 3, that's not close enough. But you could have done 2 and then 2.5. It didn't have to be 3. I could have done 2.5 and get a bit closer and closer. But if you want to get really close, it should be 4. So what I'm teaching you today is how do you do it by hand to get that 4, to get a gradient of 4. You do it on the CAS to get the equation. I'm teaching you how to find the gradient. Here we go. So we proved gradient should be 4. Let's do it by hand now to prove that's actually going to be 4. Here we go. Let's start off. Your function was x squared. You picked at f of 2. So it gave you 4. So you got the first point is 2, 4. Okay? Then you have to pick a second point. But the second point See, I said it could have been 2.5, could have been 2.1, and then Olivia said maybe 2.00001, right? But regardless, I need a second point. You only got 1 point. So to get this one, you can keep changing that number. We don't know what h is. So what we do instead is we do this. We say, well, since the number can get infinitely small, why don't I just say 2 plus a very small number? So h represents small number. You see that? So before was 2 plus 1, that's how I got 3. 2 plus half, 2.5. 2 plus 0.001, h represents a small number. So how do you find the y value? The y value is the result of substituting the x coordinate into your function. Yeah? Because f of 2, so 2, you said sub 2 into this equation, 2 squared gave you 4. So if I asked you now, well, what if x is 2 plus h? Then you would say f of 2 plus h. You see what I'm doing there? The confusion here is a lot of students, it's the struggle of working algebraically, abstractly. So you can work when I say numbers, like you see if I say, what's f of 2 plus h then? So here, I'm going to teach you some CAS just in case if you don't want to do this by hand. But what you're doing now is you've got x1, y1, you have x2, y2. Let's find the gradient using first principles. So here we go. First principle says, I'm going to cross this down so you can start it fresh. Limit of h approach 0, meaning the h number that you're picking is going to be a very small number. We just don't know what the number is. It's just very small. You said f of x plus h, which is f of 2 plus h, because I'm picking the second point to be really small, so that's y2, minus y1, which is f of 2, divided by x2, which is 2 plus h, minus x1, which is 2. Now I'm going to label them so you can see. So this is y2, y1, x2, x1. You see that? 2 points. x1, y1. Here's my second x coordinate. Here's my second y coordinate. All right. Now that you got this, can you see the 2's always cancel out? That's why the formula doesn't include the original number. The 2's will cancel out. 2 take away 2 cancels out. You just need to now work out what is f of 2 plus h take away f of 2 divided by h. Now f of 2 you already know. What's f of 2 again? That's the y value when you sub 2 into the equation. 4. So this one should technically be 4. Now let's work out what f of 2 plus h is. Let's write it on the side. F of 2 plus h just means you're substituting 2 plus h into the equation, and it should be 2 plus h squared. Now you've done some quadratics already. What's that expanded? What's 2 plus h squared?
4 plus 4h plus h.
Beautiful. This is your y2 value. So let's sub it in. So if I write in the next line, we now know it's 4 plus 4h plus h squared. That's your f of 2 plus h. Minus, you told me f of 2 was 4. All over h. Clearly in the numerator, what can cancel out? 4. 4 take away 4 cancels out. Let's rewrite the line again, and hopefully you start to see where the formula actually leads to finding the gradient. You have 4h plus h squared divided by h. What's common about the numerator? Factorize it. If you factorize it, what do you get? H is a common factor. What's inside the brackets? 4 plus h. But because you're also dividing by h, what happens to the h's? They're gone. H divided by H is 1, cancels out. And now here I want you to do some logical thinking right now. Limit as H approaches 0 of 4 plus H. This is where the theory comes in. You have simplified doing y2 minus y1, all of that. This is the key part. What makes it year 11 content. If H is approaching 0, meaning that distance between the first one and the second point, you're making it infinitely small. Because we started off with 3, so 1 unit away. Half unit away. Then 2.1 was Una's one. And then Olivia's one was 0.0001 away. What if I made H smaller than 0.001? So what's 4 plus? A very, 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 very infinitely small number. What does it tend to?
4.000.
Exactly. Now we can say, hypothetically, conceptually, if you went on infinitely small, technically the number is as close to 4. Because the closer you get it close to, it'll be closer to 4. So that is the gradient of the tangent line, which you just proved. But that was a long way of doing it, wasn't it? It was a very long way of doing it. That's why year 11s don't do that process anymore. But it holds the theory. You guys, in the next session, even if you didn't understand what I just taught you, I can teach you a formula and you'll get the answer in 2 seconds. Yeah, you'll get it in, you'll get 4. But that formula comes from this theory. This theory starts off you saying, what if H, you do pick 2 points, but what if you made H infinitely small? This is what first principles is, on a theoretical point. Cool? That was a lot to take in. I'm not saying it's easy. I am really challenging you on this theory, but like I said, it's not assess, but it's trying to intro you to the theory. At the end of the day, if you don't get theory, you can learn the process. But what separates you from someone else, like when it comes to the end of the year 12, is how well you understand the theory. Because if you understand the theory, then you can apply it. Otherwise, you're just robots following what I tell you to do. Yeah? So, that's 4 plus H. I've got one last example for you to try. So, on your sheets, where's the second sheet? This one now, I set up the working out for you to try and do what I just did.